Hi, this is going to be the video 3 for for intelligent agents. So in this video, I'm going to speak about the environment, typology, or nature. So the design of rational agents implies to define aspects related with the environment, also called the task environment. For this purpose, Russell and Nervich have defined the following acronyms, which is PS. P for performance, E for environment, A for actuators, and S for sensors. So the first step when you are designing an agent consists in defining in the best way possible which performance measure to use, the P, which environment the agent is going to operate, the E, the actuators to use, A, and the sensor to use, S. So some examples in the following tables we are going to see some examples of the classification of these PS descriptions. So for instance, if you are considering the autonomous taxi driver, the performance measure that we can use is, so for instance, is safety, speed, comfort, and profit. The environment where the agent is going to operate are the roads, the traffic signs, pedestrians, clients, etc. The actuators can be the steering wheel, the accelerator, the brakes, the clutch, gears, horn, etc. And the sensors, you can have the cameras, sonar, GPS, velocity sensor, acceleration sensor, motor sensors, and so on. So, for instance, if the example is a medical diagnostic system, the performance measure that we can use is to have the patient as healthy as possible. The environment, okay, we can have to consider the patient, the hospital, the doctors, the nurses. Some actuators are monitors to provide information about diagnostic tests, treatments, and sensors also can be the keyboard or tactical screens are some examples. Just in the case of the robot pick and place, the performance can be the percentage of parts that are correctly sorted. The environment consists of the conveyor belt, the deposits for the parts, actuators are the motors, and sensors can have the cameras and sensors, etc. So if it is, for instance, a controller to operate a refinery, an industrial controller, so the performance can be to maximize the product, quality, the profit, performance. The environment can be refineries, operators. Actuators are the valves, motor, pumps, displays, heaters, filters. And the sensors can be for temperature and all the other pressure, level, flow, etc. So the properties can be defined with some properties. So it is important to identify these characteristics, and the most common are these ones. If it is the environment is observable or partial observable, if it is deterministic or stochastic, if it is episodic versus sequential, static versus dynamic, discrete versus continuous, and single agent versus multi-agent. We are going to see each one of these. So uh, the environment is completely observable if the agent has access to the full state of the environment in each instant. Okay, otherwise it is not fully observable. Uh, you have to note that the sensors are prone to have noise associated, and also there is some lack of information often collecting data with sensors. An example, the vacuum cleaner, when it is in the A position, in the A square, doesn't have any information if there is dirt or not in the position B. So we have to say that it's partially observable. Okay, regarding the deterministic versus stochastic, we can say that if in in the current state the next state is completely determined by the current state, then the environment is said to be deterministic. For instance, the simplified or very simplified vacuum cleaner is deterministic because the next action is always determined by the previous one. Otherwise, it is stochastic. For instance, the taxi driver example is stochastic because you can never know what is going to happen in the next state. So, in the kind of episodic versus sequential. In an episodic environment, the agent perceives and executes a single action. So the next episode does not depends in any way from the actions in the previous one. For instance, if you have classification object examples, these are a kind of episodic environment. In a sequential environment, the current action has influence in every future decision. For instance, the taxi driver is one of these sequential environments, and the chess games also is a sequential environment. Regarding the static versus dynamic, when we can say that the environment is dynamic when it can change, can be changed while the agent is deciding. Otherwise, it's called static. For instance, in the taxi driver example is dynamic because the environment can change while he's taking a decision. But in the case of the solitary game, it is static because when the player is deciding, the game does not change. Regarding the discrete versus continuous, this distinction between discrete and continuous applies to the environment state, to the form used to represent time, and to the agent perceptions and actions. So, in the chess game, without considering the use of the clock, as a discrete set of distinct states, as a discrete set of perceptions, and a discrete set of actions. Okay, so it is a discrete case. In the case of a taxi driver, it has a continuous set of infinite states. It is a problem with continuous time, and so the velocity, acceleration, and position are continuous variables, and the majority of actions are continuous. So it is a continuous example. Then we have the classification between single agent and multi-agent. This is very simple to distinguish in many cases. For instance, in an agent solving a crossword games operate in a single agent environment. An agent playing a chess game operates in a multi-environment case. In this case, it has two agents. So it is important to know what type of properties does the majority of real problems or problems of real world have. Okay. One example that I am going to give you so you can try to sort it, it's this one. For instance, the solitary without clock it is observable or partially. Of course, it is partially because you cannot observe the full wall, so I'll say it is partially. It is deterministic or stochastic. I think it is deterministic, so I'll put it here, deterministic. It is episodic or sequential. So the next action depends on the previous one, so it is sequential. I'll put an S here. It is static or dynamic. Okay, when it was previously said, when it is deciding, it doesn't change, so it is static. Because it is static. And discrete or continuous. The states are discrete, so it is a discrete case. And single agent and multi-agent, it is of course a single agent problem. Okay. So I leave you to try for the medical diagnostics, the robot, pick and place, and the taxi driver to fill this table. So to conclude, I just present the references, and I thank you for your attention.